What if two of the greatest minds in science, Sir Isaac Newton and Albert Einstein, sat across from each other to debate one of the most biggest mysteries in the universe? Gravity. Would Newton's famous falling apple convince Einstein that gravity is a pulling force? Or would Einstein turn Newton's world upside down with his revolutionary idea that gravity isn't a force at all, but a bending of space and time? In this epic What If Showdown, we're going to imagine exactly how that debate might have actually played out. Einstein, welcome. I trust you come to admire my work on gravity. It has served humanity for centuries. Admire it? Absolutely, Sir Isaac. Your law was a masterpiece. But I think I've won a deeper truth about how gravity works. Deeper truth, you say? Well, let us begin. But be warned, my law has stood firm for over 200 years. Gravity is universal. Every mass attracts every other mass with a force. The bigger the mass, the stronger the pull. The farther apart, the weaker the pull. The law is simple and precise, and also it works. These equations explain everything: the falling of an apple, the orbit of the moon, and even the motion of planets. I was first to unite the heavens and earth under one universal law. My predictions sent Halley's comets across the sky and guided sailors across oceans. No one doubts your genius, Isaac. Your math still works very well for most things. Newton's law of universal gravitation, published in 1687, was revolutionary. For over 2 centuries, it perfectly predicted planetary orbits, tides, and the path of comets. To the world, Newton's gravity was absolute truth. But there were small mysteries he couldn't explain. But Isaac, there is a problem. Your law treats gravity like a magical force pulling objects across empty space. How can something act instantly at a distance? That's not how the universe works. Gravity is not a force at all. Massive objects bend the fabric of space and time, and other objects simply follow these curves. The sun doesn't pull Earth, it curves space-time, and Earth moves along that curve. Space? Bending? Nonsense. Space is empty. How can emptiness bend? Think of space-time as a stretched rubber sheet. Place a heavy ball in the middle, it makes a dent. Now, raise a smaller ball nearby, it doesn't go straight, it curves. That is gravity, Isaac. So, Einstein's general theory of relativity, published in 1915, replaced Newton's holding force with the concept of core space-time. It solved puzzles Newton couldn't, like the strange orbit of Mercury and the bending of starlight during a solar eclipse in 1919. Oh, you will say when the apple fell on my head, it wasn't because of my perfect law. It was following some invisible curves. Exactly. The apple is simply following the straightest possible path in a curved space-time. Your law works because for smaller objects and low speed, the curvature is so tiny it looks like a force. An approximation, you say? My equations guided humanity to the moon. True, but when we built GPS satellites, we had to use relativity. Without my theory, your GPS will be off by several kilometers every single day. I admit that is impressive. So, your theory doesn't destroy mine, it extends it. Precisely. You lay the foundation, I build upon it. For everyday life, bridges, rockets, even sending men to the moon, your equations are perfect. But for black holes, gravitational waves,
and the Big Bang, my theory rules.
So, according to you, space-time bent itself just to make this apple eat me on the head?
Yes, Isaac, space-time has no mercy on you.
And that is how two history's greatest minds might have debated gravity. Newton, the master of forces, and Einstein, the genius of space-time. Both correct in their own ways. Newton gave us the law that built our world, and Einstein gave us the theory that explained the universe. So, who do you think wins this debate? Tell us in the comments, and don't forget to like, share, and subscribe for more What If Science Showdown. See you in the next video. Thank you. Bye bye. See you next time.